Hey everyone, Mr. Fugay here, and today's video is going to talk about the segment addition postulate. But before we get into what the segment addition postulate is, let's look at it from a perspective of a map. So here you have a screenshot on Google Maps, and I have some cities listed. So I have the city of Philadelphia listed down here in the bottom right. I have the city of Harrisburg listed here, and lastly I have Toledo, Ohio listed down here. Now you might notice here in some of the drawings, what I have listed is that the distance from Philadelphia to Harrisburg is 95 miles. The distance from Harrisburg to Toledo is 360 miles. So quick thought here. Based on the information provided on the screen here, what is the distance between Philadelphia and Toledo? If you say it's 455 miles, then you would be 100% correct. The other part that you would be 100% correct on is that you've just applied the concept of the segment addition postulate. See, rather than looking at a map, maybe I would provide a drawing like this instead. Maybe I would provide a segment, and I would call the segment P, H, and T. And HP, let's say, has a distance of 95, and the distance of TH is 360. So the question from the geometry perspective is, what is the length of segment TP? And in this case, like we said, it's going to be equal to the length of TH plus the length of HP. Therefore, this is where our conclusion comes from. We can take the 360, the length of TH, the length of HP, which is 95, and we know that adding those two together will give me the distance between point T and point P, which in this case we are going to get the exact same result as you got from the map, 455. So this is the concept of the segment addition postulate. So let's take a look at some of our notes then. The segment addition postulate is the sum of the parts, and it equals the whole. So another way to think about this is if I give you a part of a segment and another part of the segment, and you add those together, you're going to get the length of the whole segment, which is exactly what we did in the Philadelphia, Harrisburg, Toledo example. So here it is. Write an equation that expresses the relationship between segment RS, segment RT, and segment ST. Much like the example we did with the Google map, we can see that there are two smaller segments, I should say, RS, so this is the first one, and then ST. So I know that if I take the segment RS and I add the segment ST to it, we're going to equal it to segment RT. Now, notice for these examples so far, I haven't been drawing the bar on top of it, and the reason why I'm not doing that is because what we're going to be doing is actually finding the measures of these, and so we don't use the bar symbol when we're talking about measurements of a segment here. And so let's put that into practice. Here it is. Find segment RT. So using the formula that we just created on the previous slide, we have RS plus ST equals RT. Now, if you're looking at this video and saying, well, this is easy, why do I even need to write an equation? We want to start with something simple that you already understand. So you should understand how to do this based on what we did in the video, or sorry, the beginning part of the video. But looking at this, this is the equation, and now we're going to say, okay, well, RS is 17, ST is 8.5, and we don't, well, we do know, but we don't officially know what RT is. So all I'm going to do is solve this equation by just combining like terms, and 25.5 is going to be the length of my RT. But as we move into now further examples in this video, you're going to see me introduce algebraic topics into this, and we're going to apply the same concept but to these more difficult problems. Here's your first one. Find segment MN this time. So MN is the unknown in this situation. So the segment addition postulate says part plus part equals whole. So MN is a part, NO is a part, and MO is the whole. So remember what we said in segment addition postulate problems. I'm going to repeat this a lot. Part plus part equals whole. So now that we have that, let's label what each of these are. MN is going to be X. We don't know what it is. We're calling it X. NO is 26. And lastly, MO has a length of 32. So now we're going to use our algebra skills to solve this. We're going to subtract 26 from both sides, and so this is going to give me a length of 6. So we now know the length of MN is 6 based on this example. Let's try another. So here's example 4. We're going to do this one together, and I'm going to have you try example 5 on your own. So in this situation, let's set it up once again. Part plus part equals whole. So we know that AB part plus BC, the other part, equals the whole, AC. We're going to now substitute what each of these things are. So we're going to say 3x minus 4 is AB. We're going to say 3x minus 4 is BC. Again, they're both happen to be the same thing. That won't always be the case. Something special is going on here, and we'll talk about that in our next lesson. But nonetheless, here's your equation. Now it's just an Algebra 1 problem. We're going to now combine like terms, so the 3x and the 3x make 6x, and the negative 4s are going to give me negative 8. It's a two-stepper. We're going to add 8 to both sides. We're going to get 6x equals 66. Divide by 6, and it looks like we're going to get x equals 11 here. So 11 is going to be our x. Now, because of the way this problem is worded, we now need to figure out the length of AB and the length of BC. So we're going to substitute the 11 that we now know is x into the expression. So we're going to have 3 times 11 minus 4. That's 33 minus 4, which is also equal to 29. So the length of AB is 29. And because, as I mentioned, BC is the exact same length, because it's also denoted as 3x minus 4, we're also going to go ahead and call that 29. So there we have it. So x equals 11, AB is 29, BC is 29. So at this point in the video, I'm going to have you pause this, and I would like you to try example number 5. Pause this video now, try the problem out, and then press play, and we'll have results. Before I go over the answer, it appears my notes have a typo, so let's make sure we fix this. GH is actually meaning to find AB, and HJ is meaning to find BC. Make that change so you know what segments to find. We're going to go over the answer right now. Here's the answers. So we have our equation set up here in red. You can take a look below. Again, part plus part equals whole. AB plus BC equals AC. We substitute the 3x from here. We substitute the x plus 16 from here. And the 32 is the whole. Then solving it, we get x equals 4. And as you can see up in blue, I did my substitutions. So AB, the typo, should be 12. And then BC is going to be 20. And oh, just in case you wanted to check if this was right, remember that 12 plus 20 does equal 32, so that would confirm our suspicions on that. Let's move on to another example, and at any point feel like pausing this if something's not making sense or you need to kind of hear an explanation, please do. This next one is actually going to not have a diagram already made for us, so we're now going to have to create this ourselves. So it says, suppose point S is between point R and T. So once again, we're going to look at a segment, and it appears in this situation we have 2 points on the ends, and then we have a point that is between. That means it's somewhere in the middle. You can put it directly in the middle, or you can put it off center. It doesn't matter where you put it, but we're going to call that S. And R and T are the segments that are on the outer edge, since it's between those points. So now that we have that drawn, let's label what is what. RS is 2x plus 10. So let me take my blue highlighter, and we're going to highlight RS, just to denote that. This is going to be 2x plus 10, and then we're going to have ST, which is going to be this green highlighted segment here, and that is going to be x minus 4. And remember, our whole here, the entire thing, part plus part equals whole, I usually use something like that, it says 21. So now that we have our diagram set up, we can set up the problem and solve it the same way we've solved the previous problems in this video. So I want to have you once again pause now that we have the drawing made, and I'm going to have you create the equation, solve the equation, and in this case, just tell me what x is equal to. Here is our solution. So once again, part plus part equals whole. So we're going to take the blue part, we're going to take the green part, we're going to add them together, and it's going to equal the whole here, which is 21. Combine like terms and solve. In this case, we get x equals 5. Of course, as an additional question, I may ask you to plug into RS. I may ask you to plug into ST, and obviously we could get those answers if we wanted to. But we're here to our final example in the segment addition postulate video, and that is number 7. And in this problem, there's a couple different things going on. So first off, I've not drawn something for you for this one. So for the final time, I'm going to ask you to pause this video at this point. And for this, I just want you to simply draw the segment for me. We're going to solve the equation together just because of the fractions, but let's set it up first by drawing a diagram. This is what our drawing should look like. So just again, remind ourselves, HJ, oh, actually, let me go before I say that. J was actually between the 2 points. So keep in mind when you were drawing it. Back to what I was saying before. So HJ is the segment part here on the left, and then JK is going to be the segment part on the right. So those are my 2 parts, and then HK is my whole. So to set up our equation, once again, this is going to be part plus part, so the 2 little segments are going to equal the larger whole segment. And here we have it. So as I do my first step here, we need to combine like terms. So the 2x and the 5x will become 7x. And then we need to note here that 1/3 and 2/3 is actually going to give me an answer of 1 here. If it didn't give me an actual whole number integer, there are some other equation tactics we can take care of for this, but we don't have to worry about that for this one. We have to move all of our variables to one side and all of our numbers to one side. It doesn't matter which way. I always like to typically move my variables to the left side. I don't know if that's what you want to do, but hey, we're going to go for it here. I'm going to subtract 1 then. So I get negative 5x equals negative 5. And so for my last step, we divide by negative 5. And overall, we get an answer of x equals 1. Like I had said in the previous examples, we could now take that 1 and we could take x equals 1 and plug it into hj, jk, or hk. This problem wasn't asking us to do that, but nonetheless, we could do that if we wanted to. So that's it. Part plus part equals whole. That's a quick summary of the entire video. Please go back and look at any of the examples as you need to, and move on by taking a look at the lesson plan and some assigned practice problems for you now to try on your own. Hope this video went well for you, and have a great rest of your day.